For an object undergoing simple harmonic motion, its speed, or velocity I guess, displacement and acceleration are all going to be changing consistently. So we're going to need to have a way to, or we're going to need to spend a little time looking at where each of those is going to be a maximum and a minimum value. So for this problem we're going to be examining a pendulum that oscillates back and forth, or right and left here. So this is what we call a simple pendulum. It's just a weight called a bob on the end of a string. So this is just string and washers hanging from my ceiling. So there's really 5 different moments that that might be of some importance. We've got this first one is when that string is all the way to the right, as far as it can get. And the next one is going to be a little bit to the right. The next one is right in the middle. Fourth one is a little bit to the left. And the last one is as far to the left as it can get. So let's just look at displacement, velocity, and acceleration for each one of those moments. So first off, displacement, for this first time, that's really far over to the right. So I'm just going to make that a big arrow over to the right. Here, it's just a little bit over to the right. Here, it's right at that equilibrium position. Here, it's a little to the left of equilibrium, and here, it's a whole bunch to the left of equilibrium. So we can see that displacement has a maximum magnitude here and here. So that'd be at either end of the oscillation. For velocity, if we watch the video one more time, this might help us to identify it. We see that it stops at each end, and then it speeds up as it gets down toward the middle. And we could also think about this in terms of conservation of energy. So when it's all the way back at one end or the other, it's got a maximum potential energy, gravitational potential energy. As it starts to fall in toward the left here, toward equilibrium, it loses gravitational potential energy and gains kinetic energy. It gets faster. So velocity at either end, well, that object was moving to the right, it's going to be moving to the left. So turns around at that point, velocity is 0. That's going to be the same at the other end on the far left side. Okay, at this point we were at the far right. Now we're moving down toward the left to equilibrium, and so we're moving a little bit to the left, but it's still speeding up until it gets down to the very bottom. That's going to be when we get to our maximum value to the left, or if we were going the other direction, this might be a maximum value to the right if we started on the left side and we're changing to the right. And I guess I should mention that that's true here as well. We could have a small velocity to the right, but small is the point. And then at this point, we have our object starting to slow down as it goes back upward. So it's losing some of that velocity. That kinetic energy is changing back into gravitational potential. So it's moving to the left, but not very fast, or moving to the right again, but not very fast. It's got some gravitational potential energy, some kinetic energy, so it's kind of a balance between those two. So for velocity, we see that the fastest it goes is right in this middle point, right as it's passing through equilibrium. And then acceleration is going to be a little bit tougher to figure out. But we can think of this one in terms of forces. When our forces are pointing most toward that equilibrium point, that's when acceleration is going to be largest. So if we look at the direction of our tension forces, you can see that here we've got our tension force going up at a pretty steep angle there, or pretty far to the left. Here it's not as far to the left. Here it's straight up, a little bit to the right, and then pretty far to the right here. So if we look just at the x component of these, we can see that, yeah, definitely biggest x component when it's far off to one side. And that's the component that's responsible for taking it back toward the middle. So when we're far off to the right side, our acceleration and our force to the in the x direction, that's going to be a big force this direction, big acceleration this way. When we're just a little bit, that's going to be a little acceleration. Here we have an acceleration of 0. Here our acceleration is going backward, so we're going back toward equilibrium just a little bit because we're just a little bit away from equilibrium. And here it's big, going back toward equilibrium. So for acceleration, we have maximum values again at the two ends, just like we had for displacement. And that's all for this learning target. We've identified acceleration, velocity, and displacement, and when they're large and when they're 0 for simple harmonic motion.